colors started to change.
Hello and welcome to the webcast for the Transporter 10 mission, SpaceX's 21st launch of 2024 and second launch in less than 24 hours following the launch of Crew 8 from Kennedy Space Center in Florida last night. The Falcon 9 rocket you see there on your screen is currently scheduled to lift off in just under 8 minutes from now from Space Launch Complex 4 East at Vandenberg Space Force Base, just a few hours north from our headquarters in Hawthorne, California. And in just about 2 hours, we do have a Starlink launch, which is scheduled to lift off from our third pad, Space Launch Complex 40 in Florida. Hello, everyone. Thank you so much for tuning in. My name is Atticus Videra, and I'm a propulsion engineer here at SpaceX. I'll be your host as we follow this Falcon 9 taking flight for its 5th time to deliver dozens of spacecraft into a Sun-synchronous orbit for multiple customers. As you might have guessed, today's launch marks our 10th dedicated smallsat rideshare program launch. Flying since January of 2021, the first 9 transporter flights have collectively taken over 800 satellites to various destinations in low Earth orbit. And today we are excited to send 53 more payloads to space today, and those include CubeSats, MicroSats, and a hosted payload. All the spacecraft that you see there in the photo on your screen will separate from the second stage across 48 deployments, and those are scheduled to start around the T plus 54-minute mark, and that will conclude just about 2.5 hours after liftoff. Now, we do expect to have telemetry for all but 5 of those deployments, and we will light our MVAC engine for a total of 4 times over the course of this mission. If you are interested, a full list of payloads are available on SpaceX.com.
Stage 1, everyone, load complete.
Now, we are currently working towards a T0 of 2:05 p.m. Pacific time, which is just about 6 minutes from now. Weather is green and the range is ready to support. If for some reason we don't launch today, we do have a backup opportunity tomorrow at the same time. The Falcon 9 rocket supporting today's mission is a 2-stage rocket. It's designed for reliable and safe transportation of satellites, cargo, and even people into space. At the very top of the rocket is the payload fairing. The fairing is a protective shell that houses all of the spacecraft, shielding them from aerodynamic heating and mechanical stress until the vehicle is outside of the Earth's atmosphere. The aerodynamic shape of the fairing also contributes to Falcon 9's overall efficiency, helping to reduce drag while the vehicle accelerates through the Earth's atmosphere. And once in space, those 2 fairing halves will separate to expose the payloads to the vacuum of space. The fairing halves will then fall back down to Earth, where they are recovered by SpaceX to be refurbished and reused on a future flight. And right below the fairing, we do have our second stage, which houses the single Merlin vacuum engine, or MVAC, and that's the engine that will take.
For starter recheck.
That's the engine that will take our payloads to their drop-off point in space. Below that second stage is the black carbon fiber interstage, where the MVAC engine is located. The interstage connects the 2 stages and houses the center pusher, and that allows the first and second stages to separate during flight. Just below that interstage is the first stage, which we usually refer to as the booster. The first stage makes up the bottom 2/3 of the vehicle, and it has 9 M1D engines at the bottom. Those 9 Merlin engines do the bulk of the work to get the rocket off the ground and up to the thinner parts of the Earth's atmosphere, and they generate more than 1.7 million pounds of thrust. And at just about 2.5 minutes into flight, the first stage will separate and make its way back to Earth, and we will be attempting to land at LZ4, which you see there on your screen now. And that landing zone is not too far from the launch pad. And as I mentioned earlier, this is the 5th flight for this rocket. This mission also marks the 250th time that a flight-proven booster will be used on a Falcon mission. And if successful, this landing will mark SpaceX's 280th landing of an orbital-class rocket. SpaceX is targeting at least 3 dedicated rideshare flights to Sun-synchronous orbit per year. We do also offer opportunities for a ride to orbit on our Starlink missions, and those launch about once per week. Our goal with these missions is to provide small satellite operators competitive pricing, increased flight opportunities, and flexibility. And on today's mission, we're flying many exciting payloads, from one that will one day help address the issue of space debris, to in-space surveillance and reconnaissance support, Earth imaging and emissions tracking, and several payloads intended to demonstrate and grow in-space technologies. Now, as the demand for rideshare missions continues to rise, our rideshare program was expanded.
Stage 1 LOX load complete.
And that program was expanded to accommodate even more small sats looking for rides to orbit. Later this year, Falcon 9 will launch the first bandwagon mission, which is a separate line of rideshare missions, and those will deliver spacecraft to a mid-inclination orbit rather than to transporters' sun-synchronous orbit. Rideshares significantly increase accessibility to space for small satellite operators around the world, and we're super excited to be able to offer these opportunities for our customers. Now, coming up next in just around 30 seconds, we should be wrapping up LOX loading on the second stage. Teams began loading propellant on the vehicle at around T-minus 35 minutes. It typically takes just around 33 minutes to load about 1 million pounds of liquid oxygen and RP-1 into the vehicle.
Stage 2 LOX load complete.
And there we go. We just had confirmation of Stage 2 LOX load completion. And with that, the vehicle is now fully loaded with liquid oxygen and RP1. And right now on your screen, you can see that white cloud venting from the TE LOX line. This is a completely normal part of the closeout process.
Ground gas closeouts.
The next milestone coming up ahead of launch is startup, and this occurs at T-minus 1 minute. This is the point at which the vehicle's onboard flight computers will take control of the countdown.
Falcon 9 is in startup.
Great news there, folks. Falcon 9 has just entered the startup state. We're just waiting on our final go from our launch director, or LD.
LD is go for launch.
And there's that go for launch from our launch director. So with that, all systems are go for Falcon 9's launch of the Transporter 10 mission.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. And liftoff, Falcon 9. Go SpaceX, go Transporter 10.
Vehicle is pitched downrange.
Downbilling. And what do you chamber pressures?
T plus 30 seconds into flight, Falcon 9 has cleared the tower at Space Launch Complex 4 East. We're just coming up on the point of throttling down to prepare for max Q, which is the point of maximum aerodynamic stresses on the vehicle. You can see
Power and telemetry nominal.
You can see some great views of the California coast down there below.
Falcon 9 is supersonic. Max Q.
And there we go. We just passed through the point of max Q, which means we have throttled the M1D engines back up. And coming up next, we do have 5 events, starting with MECO, or main engine cutoff, stage separation, stage 1 flip, second engine start 1, and then the beginning of boostback burn. Today's mission is what we refer to as a return to launch site mission. And that means that the first stage will flip around and point back towards the launch site where it took off from, and it will perform a boostback burn. Should be coming up on main engine cutoff in around 30 seconds. Getting a great tracking shot of the vehicle from the ground here.
MECO. Stage separation confirmed. And back ignition. Stage 1 boostback startup.
Wow, beautiful views here. You just heard and saw those 5 events that happened back to back, including main engine cutoff, stage separation, stage 1 flip, second engine start 1, and the beginning of boostback burn. On the left side of your screen there, you see the first stage performing its boostback burn, heading towards the launch site. And on the right is the MVAC engine continuing to accelerate our payloads into orbit.
Fairing separation confirmed.
And there go those two fairing halves. You can now see all of our payloads exposed to the vacuum of space. We should be wrapping up the boostback burn on the first stage in just around 10 seconds.
Stage 1 boostback shutdown.
There we go. We just had confirmation of the end of boostback burn. The next major milestone coming up is the entry burn on our first stage, and that's scheduled to occur around the T+6 minute mark. Now on the right side of your screen, we're currently in the first of 4 MVAC burns, and this burn should last for another 4 minutes or so. And as I mentioned, the next milestone will be the first stage's entry burn, coming up in just a couple minutes. For those of you who are unfamiliar, Falcon 9 performs 2 burns in order to land. The first burn of the 2 is the entry burn, and that slows the vehicle down before hitting the denser parts of the Earth's atmosphere. And without this burn, we'd only be using the atmospheric drag to slow the vehicle down, which would add a significant amount of stress on the rocket. So for today's mission, a single Merlin 1D engine will relight for this entry burn. And following that entry burn, the booster will go through the final burn, which is the landing burn, and that'll slow the vehicle down just enough to make a soft landing on our landing pad. You can see there on the left side of your screen a view of the booster. Falcon 9 is equipped with 4 hypersonic grid fins, and those are positioned near the top of the first stage. And these help steer the vehicle as it returns to Earth. Wow, on the left side of your screen, you can see a great ground tracking shot of the first stage. Those white puffs coming off Falcon 9 are...
Vehicles are on a nominal trajectory.
Those are cold nitrogen gas, which help with our attitude control. And this is just making small adjustments to the vehicle as it heads back towards the landing zone. On the right side of your screen, MVAC is continuing to burn towards orbit, currently traveling over 11,000 kilometers per hour. Again, coming up on that entry burn on the first stage in around 30 seconds. The entry burn will slow the vehicle down, so pay attention to that telemetry in the bottom left side of your screen.
Stage 1 entry burn startup.
And there's that startup of the entry burn. This burn should last just around 20 seconds. We can see the vehicle rapidly decelerating now.
Stage 1 entry burn shutdown.
And there we go. That concludes our entry burn. The first stage has 1 more burn left prior to landing. And again, as I mentioned earlier, we will be attempting to recover this booster for the 5th time today.
Stage 1 FTS has saved.
The Falcon 9 first stage is equipped with 4 landing legs made of carbon fiber and aluminum honeycomb.
Vehicles are on a nominal trajectory.
We should see those
Stage
legs
1 is
deploy just
transonic.
prior to landing. On the left, you can see a tracking shot of the first stage, and on the right, you can see the onboard cameras looking down towards the ground. Should be starting up that landing
Stage
burn
1
any
landing
second.
burn. Landing leg deploy. Stage 1 landing confirmed.
Wow, what a view of that landing, folks. As you just saw and probably heard, we did just successfully land the first stage back at landing zone 4. So that marks the
Stage 2 internal guidance.
That marks the 5th landing for this specific booster. It also marks SpaceX's 280th landing of an orbital class rocket. Next milestone coming up in just around 15 seconds should be the shutdown of our second stage engine, the MVAC.
MVAC shutdown.
Nominal parking orbit.
And there we go. We just had confirmation of successful MVAC shutdown and a nominal parking orbit insertion. Coming up next, we do have the second burn of our MVAC engine.
Stage 2 FTS is saved.
That second burn should start around the T plus 50-minute mark. So we'll be back here in just about 40 minutes to bring you live coverage of second engine start 2. Following that shortly will be the beginning of our payload deployments. So until then, enjoy the space views, and we'll see you soon.